Chapter 2, Lesson 1, Earthquake Risk. Where do earthquakes occur? The map below shows where earthquakes occur on Earth. Few earthquakes occur in the middle of a continent. Most earthquakes occur in the oceans and along the edges of the continents where tectonic plates meet. Earthquakes and plate boundaries. Notice the pattern in the map between earthquakes and plate boundaries. Earthquakes result from the buildup and release of stress along plate boundaries. Imagine bending a stick until it breaks. When the stick snaps, it vibrates, releasing energy. Earthquakes release energy in a similar way. Earthquakes are the vibration in the ground that result from the movement along breaks in Earth's crust. These breaks are called faults. A fault is a break in Earth's crust along which movement occurs. Why do rocks move along a fault? The forces that move tectonic plates also push and pull rocks along a fault. If these forces become large enough, the blocks of the rock on either side of the fault can move past each other. The rocks might vertically, up and down, or horizontally, sideways. The size of an earthquake depends on the amount of force applied to a fault. The greater the force applied to a fault, the greater the chance of a large and disruptive earthquake occurring. Earthquakes can occur anywhere between Earth's surface and depths of greater than 600 kilometers. How are earthquakes measured? Earthquakes range from barely noticeable vibration to devastating waves of energy. Magnitude describes the amount of energy released by an earthquake. Scientists have developed several methods for measuring an earthquake. Earthquake magnitude. The Richter magnitude scale is a numerical rating system that measures the energy and magnitude of the largest seismic wave produced by an earthquake. This scale is based on the height, amplitude of earthquake's waves. The waves are measured using a tool called the seismograph. The Richter scale had amount of ground motion at the given distance for an earthquake to determine magnitude. Each increase of 1 unit on the Richter scale represents 10 times the amount of ground motion. For example, a magnitude 8 earthquake produces 10 times greater shaking than a magnitude 7 earthquake does, and 100 times greater than shaking than a magnitude 6 earthquake does. The difference in amount of energy released by the earthquakes are even greater than the difference between the amplitude of their waves. For each increase of 1 unit on a scale, an earthquake releases 32 times more seismic energy. For example, a magnitude 6 earthquake releases approximately 1,024 times more energy than a magnitude 4 earthquake does. Moment magnitude scale. When an earthquake is first reported, the Richter magnitude scale is usually applied first. After further study, the moment magnitude of the earthquake can be determined. The moment magnitude scale is a rating scale that measures the energy released by an earthquake, taking into account the size of the fault that breaks, the motion that occurs along the fault, and the strength of the rocks that break during an earthquake. Both scales measure the magnitude of an earthquake and can produce similar readings. However, the moment magnitude scales uses newer technologies to produce a more accurate measurement of an earthquake. Modified Mercalli scale. Another way to measure and describe an earthquake is to examine the amount of damage that results from the shaking. Shaking is directly related to the intensity or strength of an earthquake. The modified Mercalli scale measures the intensity of an earthquake based on the descriptions of its effects on people's structures. The scale ranges from 1 of an earthquake to the people that don't feel it to an earthquake that destroys everything. The higher the number is, the greater the effect. Earthquake damage. The amount of damage from an earthquake depends on the strength of the earthquake and the nature of surface materials, the design of the structures, and the distance of the epicenter. The epicenter is the point on Earth's surface directly above the energy from the earthquake is first released. Often the area closest to the epicenter will suffer the most damage. What factors affect the amount of damage caused by an earthquake? Earthquakes are relatively common along plate boundaries. An earthquake of a magnitude 5 can devastate one area along boundary, yet cause little harm to another area. Many factors determine how much damage an earthquake causes. These factors are also called earthquake hazards. Scientists can help prevent some damage and loss of life by identifying an area's earthquake hazard. Structural failure. A nearby guitar string tuned to the same frequency will begin to vibrate by itself in response to the sound waves traveling through air. This is resonance. Seismic waves can generate the kind of resonance in the structure tuned to the same frequency of the seismic waves. This can result in structural failures. Structures can fail in different ways. They can fail when supporting walls are weak or when the height of a building causes a building to violently sway. The table below describes two ways structures can fail. Structural damage. The first one is pancaking. Pancaking happens when the supporting walls of a ground floor of a building fail. This causes the upper floors to fall and collapse as they hit lower floors. The resulting debris resembles a stack of pancakes, so the process is called pancaking. Building height. Structure failure can result because of the height of a building. All structures have natural frequencies of vibration. Tall buildings sway with a natural period that depends on their height and other factors. The higher the building, the longer its natural period of vibration is. Seismic waves with the same period of that of a tall building can cause building to sway violently and collapse during an earthquake. Land and soil failure. In addition to factors related to building structures, an area's geology can contribute to structural failure. The shaking of an earthquake produces more damages in area covered by loose sediment than it does in places built on solid bedrock. Wet soil can be strong most of the time, but the shaking from an earthquake can cause it to act more like a liquid in a phenomenon called liquefaction. The liquid ground is not strong enough to support heavy buildings, so part of a building can sink into the ground, causing the building to collapse. Liquefaction is responsible for most damage of the building. After an earthquake occurs in sloping areas, earthquakes can trigger massive landslides. A landslide is a rapid downhill movement of soil, loose rocks, and boulders. Tsunami. When you have learned about hazards associated with earthquakes that occur on land, what happens when earthquakes occur on the ocean? A tsunami is a large ocean wave generated by vertical motion of the seafloor during an earthquake. A tsunami can be caused by an underwater earthquake. Far from shore, a tsunami has a short wave height, often less than 30 centimeters high. However, the wavelength of 100 kilometers long, as tsunami nears shore, it slows down and grows higher. Many tsunamis grow only a few meters high as they move onto shore. Some can rise as high as 30 meters. The water from a tsunami is driven by powerful energy from an earthquake. As a result, tsunamis can cause major damage. What determines if an area is at high risk for earthquakes? Earthquakes can be devastating to places and people. For this reason, scientists work hard to determine when and where earthquakes will likely occur. An area's earthquake risk is based in a part of how often it experiences an earthquake. Areas that experience the most earthquakes are at greater risk. In the United States, the highest risk for earthquakes occurred near plate tectonic boundaries of the western states. The transform plate boundary in California, the convergent plate boundary in Oregon, Washington, and Alaska had the highest earthquake risk. However, not all earthquakes occur near plate boundaries. Some parts of the central and eastern United States have high earthquakes risk for the past activity. Their risk is based on their geological history. Areas that experienced earthquakes in the past will likely experience earthquakes again. How can scientists predict when an earthquake will happen? The probability that you will be affected by an earthquake depends on where you live and whether the area experiences tectonic activity. Scientists can tell you how likely it is that in your area will experience an earthquake, but they cannot tell you exactly when the earthquake will occur. Predicting earthquakes. Earthquakes cannot be predicted reliably, but scientists can determine where earthquakes are most likely to occur in the United States. This helps cities plan for further earthquake events. Cities can take action to reduce damage and loss of life. Areas at high risk of earthquakes help drive the need for earthquake-safe technologies, reducing the impacts of earthquakes. Scientists evaluate risk in several ways. They study the probability that an earthquake will occur in an area. They study the past earthquake activity, the geology around a fault, the population density, and the building design in the area. Engineers use this risk assessment to design buildings that can withstand the shaking during an earthquake. City and state government officials use risk assessments to help plan and prepare for future earthquakes. Given the damage earthquakes can cause, it is important for scientists to learn as much as possible about earthquakes to try and reduce their impact on society.